Well, hello everyone. This is a small video to talk about the problem scenario that is analyzing an F16 engine and its components. So first, I will share a screen. So here we are with the document and our report related with this problem scenario. What the problem scenario asks us to do is to analyze the components of the F16 engine, and to determine if this plane fell because of an impact of a missile or for something else. With that established, we can continue. So first of all, we determine the which components are the closed and the open devices. We can see that the open devices are the compressor, the combustion chamber, and the energy exchange, turbine, afterburners. So now, talking about the closed devices, we have the fuel tanks, heat exchangers, engine casing, and that will be all. For this case, we will be studying more the components about the turbine, compressor, diffuser, and if I'm not wrong, the la tobera de escape. So with this, we can continue with our analysis. So first of all, we use the first law of thermodynamics to analyze all the components. So first we have the diffuser, where it has a law which has a calorific loss of 50 kilowatts, a final velocity of 0.c Mach, and a mass flow of 124.7. Our assumptions were that the temperature one was ambient 20 degrees, so it equals to 293 Kelvin, and the velocity one is 1 Mach, 343 meters over second. We apply the first law of thermodynamics, and the final temperature gave us minus 70.6 degrees Celsius. Now, going with the ventilador.
So for the ventilator, we had many info at the beginning. We use the first law of thermodynamics. First, we needed to um, know the flux which goes into the nucleo of the engine. Um, so after we use the first law of thermodynamics, and we found could you go down, please? We found the work done, which was 327 kilowatts. And then with the compressor, we use mainly the velocity and the difference of enthalpy to find again the work done, which is 145 kilowatts. We work a bit on the pressure, but the calcul didn't go well, so we couldn't find the real density at the end because 13.6 kilogram per meter cube is a bit high for just a compressed air.
So now, talking about la turbina de alta presión, well, the high pressure turbine, we have the next data. We have heat, it's a lot his rate of 19 kilowatts. It's a lot. Velocity one of 1.428 Mach equals to 489.804 meters over second. The temperature one of 1510 degrees Celsius, and the final temperature of 650 degrees Celsius. And our mass flow is about 124.7 kilograms over second. So it is the same. What we want to calculate with in this turbine is the final velocity. So we apply the same law, the same equation of the first law of thermodynamics, and here we have it. So we can see here all the process to calculate V2, and it gave us 1,559.636 meters over second.
So then for the turbina de baja presión, we had the initial values of temperature of the gases when exiting and an estimated heat loss. We also took some of the data from the turbina de alta presión, and we were searching for velocity too. So we used the formula that we always use, which is Q minus W equals the change in enthalpy plus change in both energies. And so basically what we did was that we replaced, we assumed there's no work and there's no potential energy change. And so we change Q is equal to change in enthalpy plus the change in kinetic energy. And we use the formula that the change in entropy is equal to Cp times the change in temperature. And so basically what we did was that we replaced, we used this formula to replace everything in terms of the velocity. And so we had that 1/2 of the velocity 2 squared equals Cp times the difference between temperatures. And so we used this equation to have the variable V2, and then we replaced all of the data that we had before. And that way we got that V2 equals 634.03 meters over seconds. And then for the tobera de escape, we used the same formula that we got from the last problem. We used it, but in this time, what we did was that we added the velocity 2 of the turbina de baja presión, which is the same one that we just got on the low pressure turbine. And then again, we just replaced the data, and we had that velocity of exit is 951.04 meters over second.
Okay, now for answering the question of if we believe that the the downfall of this plane is due to the missile impact, or it's something else. For example, in this analysis, I believe that, well, this is something personal. I believe that it's that the downfall of the plane was due by the missile impact, because it says that the missile was launched with a velocity of 2.8 Mach, while the F-16 plane was at the velocity of 0.7 Mach. A part of that, it increases his velocity to, let me see, it increases his velocity to the maximum velocity, but I believe it that the downfall of the plane was due for the impact missile. Do you agree with the statement that I gave, or do you have something else to discuss?
Yes, I agree. If we just have to compare the two velocity, the velocity of the plane and the velocity of the missile, I agree with you, but I think it's a simplification we had to make. But in a real life, we should have take in consideration the angle of the missile, the position of the missile. So I think in this case, this is the missile is the cause of the downfall of the plane, but in real life, we should have take a lot of information in consideration.
Maria Jose, do
Yes.
you have? Ah,
Yeah. Yes, I agree. I think we can assume that it was the missile because we can also see that the plane was working fine. However, I also think it's important to take into account different aspects of how the impact would happen in real life, because now we're just taking into account like all the data, and like we have some assumptions and like assuming that it worked ideally. So I think we also need to take into account different aspects, but I think it's for now it's safe to assume that the cause of the fall was the missile.
Okay, now talking about what do you think really happened to the Captain O'Grady fighter? Well, I believe that he didn't survive the impact. Surviving a missile impact is something really hard or even impossible, even if he's flying at 15,000 meters. There are many considerations. For example, if he ejected at the correct time, but I don't believe so. So I believe the that the pilot died in this incident.
I agree with that. I couldn't add more to this.
Yeah, I also think even if he would have survived the impact, it would be very hard for him to survive the actual fall of the plane. So I think the same.
So, okay, so that would be all, and thank you for listening.